Miles below the Earth's surface, there's a source of renewable energy that could sustain all of humanity for the foreseeable future. Just 0.1% of Earth's total heat content could meet our energy needs for 2 million years, according to ARPA-E, the government agency that funds R&D efforts for advanced energy technologies.
It's more than we could use in our entire arc of civilization thousands and thousands of times over.
It's called geothermal energy, and in some ways, it's old news. It's been used to heat buildings since the late 1800s and to provide electricity since the 1900s. But though the US has the most installed geothermal capacity in the world, it still only accounts for about 0.4% of our total electricity mix. And we almost never hear about it.
Because geothermal has been around for over 100 years, it just doesn't have the same kind of cachet that some new energy source has.
Though newer geothermal technologies are essentially emissions-free, it's expensive and technically challenging to drill geothermal wells. The hotter and drier the rocks are, the more difficult it is. And now that natural gas, wind, and solar are so cheap, there just hasn't been much economic motive to scale geothermal in more difficult geographies. But that's changing.
Fast forward a few years and it's a very different world. I think the volatility of the oil and gas sector, as well as this increased focus on climate change and the environment and sustainability, have really caused these companies to wake up and realize that the energy transition is going to totally change how business is done.
Now oil and gas majors like Chevron and BP are getting into the game, making investments in the geothermal space. It's a natural fit as the skills required for drilling oil and gas wells are quite similar to drilling for geothermal, and technical innovations from the shale revolution are making the economics more feasible.
Most of the heavy lifting was already done by the oil and gas industry in the last 5 or 10 years. We're sort of riding on the coattails of their advances in directional drilling and speeding up drilling.
We spoke to a number of startups in the geothermal space, gearing up to demonstrate their tech or developing their first commercial projects, all hoping that their approach will help get the world to 100% renewable energy.
I feel like geothermal is where mobile phones were in the 1990s with these big clunky models that nobody could afford, whereas now there's a mobile device in everybody's hand.
You can just feel that we're in early innings of something that people are just recognizing what a transformative impact is going to have on the world.
The most obvious sign of geothermal energy is when it breaks the surface, creating hot springs or geysers.
The first geothermal power plants that were developed over 100 years ago were put in places that were so hot that the steam was literally coming right out of the ground.
Today, there are over 60 geothermal power plants in the US and 29 countries using geothermal power. But technology and costs have limited where we can build geothermal plants. Right now, it's mostly confined to very specific geographies, where naturally porous, fractured rock creates a reservoir of hot water, allowing the heat from the Earth's core to rise to the surface.
All geothermal essentially works the same way. You drill deep wells down to access this hot part of the Earth, and you pump cold water down that goes through the hot part of the Earth and returns back as hot water or steam. And that's captured at the surface to turn a turbine and create electricity. And so it can work for decades. It works round the clock 24/7. The challenge for geothermal power has always been, how do you get it to work in places where you have to drill deeper or where the geology is less uncertain?
Basically, unless you can see a geothermal feature like a hot spring or a fumarole, there's no way to be certain that there's a reservoir of hot water below. Another challenge is the high upfront cost, which dwarfs that of a solar or wind farm. But if you can figure out how to finance it and where to build it, geothermal has some major advantages over other renewables.
We always talk about electrical power, but of course there's this massive other market that wind and solar don't play in at all, and that's heat.
Geothermal can be used to heat buildings much more cost-effectively and directly than solar or wind power, which needs to be converted into electricity first. And you can build geothermal plants close to population centers.
For much higher density, so you can fit us in urban areas, put us on tiny islands. You don't have to blanket entire valleys with solar panels.
Perhaps most importantly, though, geothermal is a renewable source of baseload power.
So it's available, 24 hours a day, 7 days a week, 365 days out of the year. Whereas solar and wind are dependent on the sun shining and the wind blowing.
When you consider that wind and solar need massive amounts of battery storage to attain the same degree of always-on reliability, the economics of geothermal definitely start to look better. Now, many experts think that it's just a matter of incremental technological improvements that will bring the cost of exploration and drilling down. hopefully one day allowing us to build geothermal power plants anywhere in the world.
It's been estimated that 98% of the world's geothermal resource cannot be adequately harvested with conventional geothermal technology. So our goal is to go for the 98%.
Arkadaşlar bu manzaraya en iyi ne gider biliyor musunuz? Open English'ten 2 al 1 öde kampanyası.
No matter where you are in the world, if you dig down deep enough, you'll hit hot rocks. Today, geothermal startups are taking advantage of technologies pioneered by the oil and gas industry to help harvest that heat, such as horizontal drilling. While most wells used to be drilled straight down, technical advances in horizontal drilling now allows for much greater access to oil, gas, and geothermal resources, which usually occupy a subsurface area that is wider than it is deep. Drilling has also simply gotten faster, as drilling rigs and drill bits have improved.
Drilling productivity for oil and gas in the United States has increased by a factor of 10 in the last 10 years.
Latimer, who used to work as a drilling engineer in Houston, founded his company Fervo Energy in 2017. Fervo uses a technology known as EGS, or Enhanced Geothermal Systems. While conventional geothermal relies on pre-existing reservoirs of steam or hot water, EGS creates a reservoir where one did not previously exist. It's basically a version of what we know as fracking. That is, drilling down and injecting water at high pressure such that the hard rock fractures. This allows water to flow through, creating a reservoir. The water is then heated by the hot rocks and brought back to the surface through the production well, where it's converted to steam that turns a turbine. What sets it apart from oil and gas fracking, of course, is that the final product is renewable energy, not fossil fuels.
We can get up to 4 times more flow rate out of a geothermal well than using traditional technology. That means costs are a lot lower. That means we can develop geothermal in way more places, make it economic, and connect to the grid in many more locations.
The Department of Energy says that EGS has the potential to generate over 100 gigawatts of electricity in the U.S., over 25 times the current geothermal production, and enough to power about 100 million American homes. Right now, Fervo is focusing on commercializing its tech in the western U.S., where both the geology and the renewable policy incentives are conducive to geothermal energy.
So we're very excited about those markets, places like California, Nevada, and New Mexico, that both have the know-how and geology to develop geothermal and have put in the right market structures to allow geothermal as a technology to flourish.
Then there are the companies pursuing advanced geothermal systems, or AGS. These include Greenfire Energy and Ever Technologies, founded in 2015 and 2017 respectively. These technologies don't rely upon a pre-existing reservoir like traditional geothermal, or on fracturing the surrounding rock to create a reservoir like EGS. Instead, it's basically a subsurface heat exchange system. The way it works is 2 wells are connected by a sealed pipe, or in Ever's case, many lateral sealed pipes. A highly conductive fluid, perhaps water, perhaps something more specialized, is circulated throughout the pipes, picking up heat from the surrounding rocks and carrying it to the surface.
Ours is a pure conduction system. There's no water going out of the rock or into the rock, no contamination, no fracking, no seismicity risk.
Ever made headlines in February after receiving backing from BP and Chevron in its $40 million funding round. Now it's looking to commercialize, a costly endeavor for them and any company in this space.
The first commercial implementation in Bavaria, phase 1 of that is 200 million euro. If we do all 3 phases, it's 2.4 billion euros. So only by partnering with companies with sort of global scale like that are we going to be able to make the impact we want in the time we want.
Greenfire, though, aims to take care of what it sees as low-hanging fruit first, modifying old existing wells with new closed-loop technology.
Our position is geothermal anywhere is futuristic. Geothermal in great locations is a present opportunity that can be expanded dramatically. And with retrofits, the capital expenditure is relatively low and the payback is relatively fast because you don't need to drill a well.
Scheer hopes this approach will allow Greenfire to prove out its tech as it moves towards building geothermal in places where the rocks are hotter and drier.
We think we could double the amount of geothermal within 15 years, for example, with new technologies, including ours.
Then there's Sage Geosystems. Recently founded in June 2020 by former oil and gas industry veterans, the company plans to use a number of well-designed solutions tailored to different conditions.
We recognize that there's not one single optimum geothermal design solution for all applications and all subsurface environments.
One of their initial solutions incorporates elements of both EGS and AGS. It works like this. First, Sage will drill a well and fracture the rock directly below it with a highly conductive and convective liquid, meaning that it transfers heat easily and the hotter matter will rise. Then, a closed-loop system will be built within that well and above the fractured rock. A fluid will circulate throughout the loop and heat up through conduction. This fluid will get especially hot because the fractures below it will be bringing up heat from deep within the earth. TAF is optimistic that by utilizing various technologies and combining elements of EGS and AGS solutions, the concept of geothermal anywhere isn't that futuristic.
With our integrated system approach, we'd like to see geothermal applicable everywhere within the next 5 years.
All of this progress in geothermal is a major opportunity for the oil and gas giants, who are seeking ways to green their portfolios while also holding tight to their core skill set, exploring and extracting energy resources from deep within the earth.
So the oil and gas industry over the last 6 or 8 months has really engaged in this to an extent that they had not historically. And there's a lot of reasons for that. A lot of carbon neutrality commitments coming out of the industry with no clear path about how to do it. They just know they wanted to do it and they've got a clock ticking on that.
European oil majors Shell, BP, and Total have pledged to be carbon neutral by 2050. American oil majors like Chevron and ExxonMobil have not yet followed suit, though they're both planning major investments in low-carbon tech.
Oil and gas entities are under enormous pressure to hold on to talent. Really young, excited, energetic, skilled workers. They're not looking at the oil and gas industry as where they want to go and work right now.
So far, American majors have seemed reluctant to invest in the most popular renewables, solar and wind. They simply don't have the expertise. But geothermal, with its focus on subsurface modeling and advanced drilling, could be an attractive option for highly specialized engineers and blue-collar workers alike, who know how to design and build wells.
It's just a perfect opportunity to take the skill base and the capital that's available from the oil and gas world and bring it into geothermal. And whether you look at it from a financial point of view or a technical point of view, it's a very obvious move.
That collaboration between the incumbent and the new party, or between the big and the small, is going to be critical in the energy transition.
Chevron and BP's investment in Ever has kicked off talk about what other funding and partnerships are coming down the pike. And Beard says that we can expect to see more tangible signs of industry interest soon.
I think that within, 5 years, many of the fledgling startup companies will have de-risked their concepts enough for oil and gas to seek to acquire them.
Now, there's going to be many different solutions in the geothermal space. Not one company will have all the answers, and so we might make multiple bets in this area.
Of course, the involvement of oil and gas majors, especially in EGS projects that involve fracking, is bound to raise some eyebrows. Experts do note that the fracking and circulation fluids used in geothermal projects are non-toxic, alleviating water contamination concerns. With regards to earthquakes, the seismic risk for geothermal projects is much lower than it is for oil and gas projects. That's because oil and gas drilling creates wastewater that needs to be re-injected back into the earth for disposal, increasing subsurface pressure and thus earthquake risk. But the geothermal process doesn't involve wastewater. Experts say that keeping seismic risk as low as possible will be vital for the industry's survival.
Just because of the negative PR that would happen from a seismicity event, for instance, in the United States near a population center. That would be devastating for geothermal.
As much action as there is in the geothermal space right now, there's still big differences among the experts about just how much of our future could be powered by the heat beneath our feet.
Geothermal electricity could make up 10% of the grid.
I always pitch this as being the 20% solution that's going to fill in the gaps where the other renewables can't reach.
I think it can be greater than 50% in the next decade.
Sure, 50%. It's easy. This is just a matter of scaling it quickly enough.
Of course, who ends up being right here largely depends on what policies are pursued, and whether government, corporations, and private investors alike are willing to invest big money in order to hone the technology and drive down the huge capital costs.
What we need is investors who are willing to invest tens of millions of dollars. So finding those unique individuals and those unique companies to invest, particularly if we're talking about hot, dry rock or enhanced geothermal systems, that's what we need.
If you look back at the success of solar and wind, the role of the government to be both a first customer, to provide financing, and to provide technology solutions for deployment was critical. We could do the exact same thing today with geothermal.
Fervo, Greenfire, Ever, and Sage are all still proving out their tech, and it remains to be seen which approach, if any, will be scalable. But however it shakes out, the oil and gas industry is well poised to play a big role in ushering geothermal into the future.
Geothermal at scale, leveraging the entire oil and gas industry global, literally solves energy.